Okay, hi guys. Today we're going to learn about integration by rational functions by partial fractions. But first, I want to show you the solution for previous example, which is example C. Okay, I think I haven't shown it yet to you. So C, the question is ex cos x dx. So remember, according to the rule, which function should we choose as u? Okay, which function? Remember, the exponential function is at the bottom of the list, so we should choose the trigger function to be u. So u is cos x and du is minus sin x dx, where dv is e to the power of x and v is ex dx is also ex. Okay, and then we want to use this formula uv v du. Okay, so u is cos x, ex is v minus the integration of ex, where du is minus sin x dx. So I'm going to rewrite it like this so it will look nicer. So this is plus ex sin x dx. What will this ever end? Do you think we have to do another integration by part at this stage? Yes, we do. We have to do it again for ex sin x. So again, what is u? U is, we choose the trigger function, which is sin x, and du is cos x dx, where dv is ex and v is ex dx is ex. Okay, put it back into this equation. Ex cos x plus, okay, I think I'm going to do it here so you will not it will be not too heavy or complicated at this side here. So uv du. So u is sin x times with ex minus v du is ex du is cos x dx. Will this ever end? I don't know lah. Okay, I'm going to write it back here. ex cos x dx. Okay, so now we have this. Do you think we should do another round of a substitution? No, we don't. Okay, because this equation here is equal to ex cos x dx. This is from the original question, right? Let's see. Sorry. Okay, original question is the integration of ex cos x dx. So the whole thing here is also equal to the original equation here, original question here. So what do we have now? So it move this, the integration of ex cos x, to the left hand side. So you have 2 ex cos x dx equal to e. Okay, now you can pull together the exponential function ex. So you have cos x plus sin x. And can we get the answer now? Yes, we can. Right, so this is like a trick question that might or might not be in your exam. So, this is the final answer for question C. E to the power of x cos x plus sin x over 2. Okay, now we want to learn about integration of rational function by partial fraction. So this is what we call is a partial fraction, which I will show you how we can get 2 here and 3 here. Okay, later. Okay, however, you must know some rules lah. So the degree, okay. So for rational fraction, the upper part is called fx and lower part is gx. Okay? Okay. So the degree of fx, the upper part must be less than the degree of gx. What is the degree? Let's say fx is x to the power of 2 and this one must be higher. Okay, then only can we do rational fraction formula. Okay, so that is rule number 1. So rule number 2, to know the factor of gx. Okay, which I think it will be more clear when we do the examples. Okay. Okay, so fx and gx. Okay, look at the power of x. So the power of the fx is less than gx. So it takes the second row. So okay, so now we have 5x minus 3 over x squared minus 2x minus 3 equal to, okay, equal to 5x minus 3, and this, the lower part, we can factor together, right? So when we factor that together, we will get x plus 1 and x minus 3. Okay, and this is the formula. Okay, ax, power of 0. Why power of 0? The power of x here, x at the upper limit must be less one level than the lower limit. So x to the power of 0 is what? Is 1, right? Okay, okay, let's say here, if you have x plus 1 square, and this one must be, okay, and if you have 3 here, this one must be 2. Okay, that's the way of the rule. Okay, let me erase this first. Okay, square ke? No square, right? This, okay. Okay, some problem with my pen, I'm sorry. Okay, so this one should be x to the power of 0 plus bx to the power of what? Of 0 also, since it is x minus 3. Okay, so now what do? We move. Okay, before that, let me write this so it will be more clear to you. So this is x minus 1 and x plus 3. Okay, so leaving 5x minus 3 here, what do we have here? X to the power of 0 is 1. So x plus 1 times with x minus 1, x plus 3 plus b over x minus 3, x minus 1, and x minus 3. So can we cancel here? We can cancel this one and this one. Okay, so now we have 5x minus 3 equal to a x plus 3 plus b x minus 1. Right. Okay, so now to find b, what should we do? To find b, let x equal to 3. To find b, why is that? Some of you can answer that question, but let me show you. So x equal to 3 minus 3 and a 3 minus 3 plus b 3 minus 1. So this one you will get 12 and a 3 minus 3 is 0. So a is, this part is 0 plus 3 minus 1 is, no, it's not 3 minus 1, 3 plus 1. Okay. I think I've made some mistake here lah. So this one is here, right? So how come it become x plus here? This is x minus. So I have realized where my mistake is. So when you factor this x squared minus 2x minus 3, make sure it is standardized to the left hand side and the right hand side. As you can see here, it is x minus 1 times with x plus 3, whereas here is x plus 1 times with x minus 3. It cannot be like that. Although the answer will get you this back, however the answer for A and B will not be the same. Okay, so now I have realized where my mistake is. So now we let here ax plus 1 and this one is x minus 3. Okay, so this one should also be okay. So this one is plus 1 minus 3 plus 1 and this is x minus 3. Okay, so okay, of course it is also cancelled out together. So this is minus and this is x plus 1. Okay, so now we are okay for this part here, it is the same. So 12 equal to 0 plus b x plus 1, where x is 3 is 4b, where b is 12 over 4. 12 over 4 you will get 3. Okay, now we have b. Let's find a. So how to find a? Okay, I hope when you listening to my lecture, you have wrote down the lecture note or the calculation also, because I'm going to erase this. Yeah. So to find a, we let x equal to minus 1. To find a, why do we choose minus 1? Okay, let's see later. So just now the equation is 5x minus 3 equal to a x minus 3 plus b x plus 1. So we let x minus 1, so this b can be cancelled out together. Minus 1 plus 1 is 0. So now we can find a. So minus 1 minus 3, a minus 1 minus 3, and this one we will get minus 5 minus 3 is minus 8 and minus 4a. So a is 2. So now we know b is 3 and a is 2, and we replace it back into the equation here. So the equation here is 5x minus 3 over x squared minus 2x minus 3. So this one will be, I'm going to write everything back. So I hope with this you will have better understanding. X minus 3 and x plus 1. So a is x plus 1, where b is x minus 3. So what is a? A is 2 over x plus 1 plus b is 3 over x minus 3. So that is how you do a partial fraction. Okay, we're going to have a lot more example after this. So I hope you will have better understanding from that other examples. So when we include in 2 over x plus 1 and 3 over x minus 3, 2 can be put outside, 3 can be put outside, right? So it will be 1. So this one will be 3 over 1x minus 3 dx. So when you do this, 1 over x is 1 over, when you integrate 1 over x, you will get ln. So this one should be 2 ln x plus 1, and this one will be 3 ln x minus 3. Okay, so now we're going to do another examples. Okay, this is example 11. So as you can see, it is a lot more complicated, but there is steps on how to solve this question. So as you can see, the order of x is, for the lower part is x to the power of 3, and this one is x to the power of 2. So it conforms to the rule of partial fraction. Okay, and then when it is factored like this, 2x minus 1 over bx plus 1 and x minus 3. Okay, remember there is x minus 0. Okay, which is equal to 1. Okay, so now we're going to do example 12, starting with 12a. So 12a is how to solve this function using partial fraction. Okay, how? So here it is to the power of 2, right? Okay, so x plus 2, okay, and b x plus 2 square. Why square? Because it is in the rule. Let's see here. Okay, let's say if you have this function xr to be a linear factor of gx. Okay, gx the ni kan. Okay, the lower part kan. So in our case we have 6x plus 7 or minus bukan minus over x plus 2 square. So our gx is x minus r here lah. Okay, for example, so suppose that x minus r to the power of m is the highest power. So the way to do it is like this. Okay, where a over x minus r, in our case a over x plus 2 plus b over x plus 2 square. Okay, Okay, that is why we do it like this. So okay, so 6x plus 7, and this one is a x plus 2 times with x plus 2 square. Put it to the right hand side, right? So 2 square plus b x plus 2 square times with x plus 2 square. So these two can be cancelled together, leaving b, and this can be cancelled, leaving with like that. So the final one will be a x plus 2 plus b. Okay, can we find a and b from here? Yes, we can. Okay, so to find b, what do we do? Let x equal to minus 2 to find b. Okay, so 6 minus 2 plus 7, a minus 2 plus 2, 0 plus b. So minus 12 plus 7, you will get what? B equal to minus 5. Okay, now we know b equal to minus 5. Let's say we let x equal to 0 to find a. Okay, because it is the easiest way. Okay, so 6, 0 plus 7, a 0 plus 2, and b is minus 5. Okay, you will have 7 2a minus 5, and you will get 12 here, 2a, where a is 6. Okay, so then put it into this equation here where a is 6. So 6x plus 2. Remember, you have to integrate this, right? 6x plus 2 dx plus with b, what is b? Minus 5x plus 2 square dx. Okay, similar with the one before. So 6 ln x, okay, modulus x plus 2. Okay, I have to erase some of this. Okay, all of this probably. So now we have, I'm going to write back here, 6x plus 2 dx minus 5 okay, minus, you can see it, okay, minus x plus, x plus 2 square dx, and 6 we can put outside, leaving this with x plus 2 dx minus 5 put outside, x plus 2 square dx. So this one is clear cut, right? So 6 ln x plus 2, whereas this one not so this is not 1 over x, because this we have here square. So okay, we have to do it like this, x plus 2 minus to the power of minus 2, right? So if integrate this, you will get x, okay, I'm going to do it the old-fashioned way, negative 2 plus 1. When you integrate, you add the value of the this one here, the upper power here, okay, and make sure it is the same for here. Oh my gosh. Okay, I hope we can do this. X plus 2 minus 2 plus 1, and the lower also should be the same as this part here. Okay, it should be the same. So leaving you with what? Can you guess it now, guys? So leaving you with minus x plus 1 ni. So this one will be minus 1, right? Minus 2 plus 1, and this one will be minus 1 also. And this can be rewritten like this. 1 negative, don't forget, 1 over x plus 2. Okay? Plus c. So rewrite it to make it look much more nicer. Plus 5 over x plus 2 plus c. So that is the final answer for A. So now we're going to do example B. Okay. I'm going to erase this first. Okay, so let's look at example B. Wow, example B looks a bit complicated. But first, looking at this function, can we do the rational function for this one? No, we can't. Okay, if we can't do it, shall we continue? Yes, we should. I forgot to ask you, why we cannot? Why this is not a proper rational function formula? Because the value of fx, okay, the power of fx here, x to the power of 3, is larger than gx, which is x to the power of 2. So first we must rectify this this equation. So what you have here is 2x to the power of 3 minus 4x squared minus x minus 3. What do we do if you come across this kind of question? You have to divide it. Okay, x squared minus 2x minus 3. So what do you think should be here? 2x, right? 2x, which you will get 2x. Okay, don't forget minus sign here. 3 minus 4x squared minus 6x. Okay, this one we get 0. This one negative 4x plus 4x we get 0. Minus x plus 6x you will get 5x minus 3. So all of this here can be rewritten like this. Okay, 2x plus what, guys? Plus 5x minus 3 over x squared minus 2x minus 3. Okay, so we're going to integrate all of this part here. Okay, in this next slides. Okay, so now we have 2x. Okay, I split it into 2, so it will make your life much more easier. So this one is 5x minus 3, and this is x squared minus 2x minus 3 dx. Okay, integrate to x, you will get 2x squared plus 2. Okay, and then integrate. Have we come across this equation before? 5x3 over x squared minus 2x minus 3. Have you remember? We have done this, right? Kan? Is it the same? Yes, it is. So now we have the solution here and put it back into, just slot it in. So the integration of that, you will get 2x plus 1 plus 3 x minus 3. So now you have x squared plus 2 ln x plus 1 plus 3 ln x minus 3 plus c. So that is how you do example B. So now I'm going to show you how to solve example C. Okay, let's look at the question here. So I'm going to erase some of this. Okay. So now we have this one. How should we proceed? Okay. So I'm going to write it back. This can also be rewritten like this, right? 1 over x squared plus 1 square dx. Okay? So what you should do is okay, the formula stating if you come across this kind of rational fraction, this is the way that you should move on to the next question. So a over x and b x plus c x to the power of 0 x squared plus 1. Why? Because this is why bx, because this is x squared. So the upper limit should have at least one level of x power higher than the lower limit. So this one is dx plus e x squared plus 1 square. Okay. So now we have, so this one you're going to integrate down later on. But we must first solve A, B, C, D, and E. Okay. So now we have A, X. Okay. This is equal to 1 and bring this part here to the right hand side. So x squared plus 1 square plus bx plus c over x squared plus 1 times with x squared plus 1 square times with dx plus e. I don't know whether we can fit in everything or not here. Times with x and x squared plus 1 square. So what can we cancel? X can be cancelled, x squared, and this can be cancelled, just 1, and x squared. Okay, leaving you with 1 equal to a x squared plus 1 square plus bx plus c times with x squared plus x, right? Okay, or it can be bx squared plus cx times with x squared plus 1 plus dx plus e times with x. So now I'm going to do it in this slide. so it will be more clearer. Okay, I'm going to write it back here. Okay, a equal to x square plus 1 square bx plus c x I think we have decided to put in x inside here, right? Bx square and cx times with x square plus 1. And what happened to dx? Dx is plus dx square plus ex. So everything of this equal to 1. So now we want to expand this function. Okay. Okay, when you expand x square plus 1 square, you will get this, right? X to the power of 4 plus 2x square plus 1 plus bx square plus cx times with x square plus 1 times with dx square plus ex equal to 1. So now we will have ax to the power of 4 plus 2x square plus 2, plus 2, plus a, 2ax square, right? 2ax square plus with bx to the power of 4 plus cx to the power of 3 plus bx to the power of 2 plus cx plus dx square plus ex equal to 0. So when you come across into this much constant, you have to do this technique, comparing the term. I'm not sure whether you come across rational function or not before this. X power on both sides. Okay. Okay. What does it mean here? Okay, first x to the power of 0. Okay, from this equation here, which one is x to the power of 0? Ada tak? Is there any? Yes, there is. Where x a, kan? Because x to the power of 0 is 1. So a is x to the power of 0 on this left hand side, and from the right hand side it is 1. So now we know the value of a is 1. So now we're looking at x to the power of 1. X to the power of 1. So we have c and e, right? Okay, do we have anything with a constant x here? No, we don't. So equal to 0. So x to the power of 2 is 2a, 2 plus b. Is this dx? Plus d equal to 0. So now we know a is 1. So we have here 2 so b plus d is minus 2. Okay. So we leave it at that, and we want to find x to the power of 3. Okay, x to the power of 3. We have c. We have c only. So this one here, there is no x to the power of 3, so equal to 0. So now we know a is 1, c is 0. Okay, can we do something about this? Yes, we can. When you know c is 0, e is also 0. Okay, so x to the power of 4. x to the power of 4 is a plus b, and that is all equal to 0 because there is nothing to the power x to the power of 0 here, right? On the right hand side. So a is 1. B, do we know b? Yes, we know now, right? So b is, when a is 1, b is minus 1. So when we know b, can we know d? Yes, we can. When b is minus 1 plus d equal to minus 2, so d is minus 1. So now we know everything. A, B, C, D, E. A is 1. B, where is B? B is minus 1. C is 0. I hope you write it down because I want to erase everything here. And D is minus 1, where E is 0. Okay. Okay. And let's, okay, now we know, right, what is the value of A, B, C, D, and E. So I'm going to erase some of this here. Okay, now we know the value of A. What is A? A is 1 over x. What is B? What is B? B is minus 1. Minus 1. So it will be minus 1 minus x. Minus x. C is 0. So leave it at that. Over x squared plus 1. Don't forget dx here. And what is D? D is minus 1. So minus again. Minus 1. Minus 1 minus x. E is 0 over x squared plus 1 square. So now can you please try to solve this on your own? Okay, because the answer is already here, and we have try to solve half of the steps. So can you try to do it on your own at home? Okay, see you guys. Okay, bye.